Okay, so my last video, we went in and we did the following. We just had a thing on force friction and force normal and the coefficient of friction, and we're going to extend that to inclines in this little video. Okay, so you'll remember a few videos back, I took a brick and I slid it across with a force of 4 newtons, which meant that friction is going to pull back the other way with 4 newtons, and the brick had a the brick had a weight of 16 newtons, which meant that there's going to be a force normal of 16 newtons. So that meant that I had a mu, which was going to be 4 newtons divided by 16 newtons. And I don't need my calculator to do that. That's 1/4, or it's 0.25. Okay, now we had a situation where I had an incline that for every 1 meter up the incline, I had a vertical rise of 0.38 meters. And I had a brick on there, and it took me 12 newtons to pull it up. And we're going to start to analyze this. So it took me 12 newtons to pull this direction. Now, what has stayed the same? Well, I know what has stayed the same. What has stayed the same is the force due to gravity. Force due to gravity is still pointing down this way at 16 newtons. And then where can we go from there? Well, we can go to this equation, force normal equals Fg cosine theta. And so what I'm going to do is I'm going to make a perpendicular, and I'm going to say that's, well, I know that that one right there is going to be Fg cosine theta, but I don't know what theta is yet. I don't know what this angle is yet. But I do know that this angle is the same as that angle. And I'll let you guys sort of figure that out. I'm going to let you guys work with that and use some geometry and figure out why that angle is equal to that angle. So what I'm going to do is I'm going to find what that angle is. Well, here I've got a triangle that's 1 meter, has a hypotenuse, and the opposite side is 0.38. So I'm going to say sine theta is 0.38 meters divided by 1 meter, and so theta is equal to the sine inverse of 0.38. And if I do that, well, let's see, second sine, so I did second sine, and let me pull that down here. Second sine of 0.38, and it's going to be 22.3 degrees. Okay, so that's going to be, it's going to be hard for me to show on my diagram, but that's going to be 22.3 degrees, and that's going to be 22.3 degrees. And so I'm going to say my F norm is going to be Fg cosine theta. Force normal is going to be 16 newtons times cosine of, what did I just say? I just said 22.3 degrees. So I plug that in, and I get 16 times cosine of my answer, and I get 14.8 newtons. Alright, now, I just calculated earlier that the coefficient of friction between my brick and that board is 0.25. Now that doesn't have to do with the geometry of it. That is a fact about that brick and that board in whatever orientation that they're in. So let me put a little diagram here. 14.8 newtons on that. And that's going to be force normal. I know that that's getting really busy here. Okay, now what we have is we have this mu equals force friction over force normal. So mu is equal to, I know mu, so force friction is going to be mu force normal. So force friction is going to be 0.25 times 14.8 newtons. So my force friction is going to be 0.25 times 14.8 is going to be 3.7 newtons. And that's going to go this way, 3.7 newtons. Okay, so now let's let's see if we can draw a scale diagram really quickly and put these all tip to tail. So we've got 4 vectors and we're going to put them all tip to tail. Okay. First off, let's go 16 newtons down, which is the weight of the brick. So it starts right about there. So that's 16 newtons down, that's force gravity. Now, 22.3 degrees above the horizontal, I have my pull. So 22.3 degrees above the horizontal, I've got my pull, and that pull is going to be 12 newtons. So I'm going to go in that direction, and I'm going to go off 12 newtons. And that's along the incline. And now my force normal, well actually let's do force friction right now. Force friction is opposing that by 3.7 newtons. So force friction is going back the other way. Hang on, let me pull it out this way. Force pull is going that way at 12 newtons. Force friction is going to go back down the incline. So I'm going to overlap by 3.7 newtons. And we'll pull it down like that, sort of double it up. That's right there. I'm sorry. So this is kind of hard to see. I should use a different color. But this is force friction, and it's going to be 3.7 newtons. And then finally, from that point, I've got a perpendicular. So those are all parallel to the surface. And so then I've got my force normal, which is perpendicular to the surface, and it is 14.8. So I go perpendicular to my surface, 14.8, somewhere like that, in that direction, and I go out like that to there, and that's not a very good. I should have definitely come up better than that. But basically, again, I'm probably off by a lot in a few different measurements. But if I was hauling that brick up at a constant velocity, then I would expect that the end of this vector would lie right on top of the beginning of that vector. That's that video.